Welcome to Comfort Learn classes. In this video, I will solve exercise questions from 5.2, that is continuity and differentiability. So here we have 10 questions. In these 10 questions, you are given some simple functions and you need to use the general formula of differentiation to find the derivatives, right? So what is this general formula? See here. If you are given x raised to n, correct? So let me take this as the given function y is equal to x raised to n. So now if I ask you to find dy by dx here, right? If I ask you to differentiate y with respect to x, so here and to just follow this formula, you take this power in the coefficient, right? Take this n here and then reduce this n by 1. N x raised to n minus 1 is the derivative of x raised to n, right? So now here if I take x square as the given function, right? If I take x raised to 2 as the given function, so then dy by dx, the derivative will be coefficient x raised to 1 less than this 2 minus 1 here, right? Or let me take one more. If I take x raised to 4 as the given function, then dy by dx will be 4 as it is x raised to 4 minus 1, right? Which is equal to 4x cube, right? So this is the general formula for the polynomial function of our algebraic expressions. So now let me take the first one. So here we have a sine of x square plus 5. Let's say how to find the derivative of sine of x square plus 5. So now if I take y is equal to sine of x square plus 5, right? So now here if you want to find dy by dx, first check the given expression. So in the given expression we have sine function and then x square plus y, right? X square plus y is a polynomial function and then sine is a trigonometric function. So here we have a composite function both with a trigonometry and then exponential, right? So in such cases, first you need to differentiate sine, and we know the derivative of sine is cos. So first you need to write cos of same angle, don't make any changes here, cos of x square plus 5 as it is, right? After this you need to find the derivative of the second expression separately. So now what I will write? I will write d by dx of the second expression x square plus 1. Fine. So now here cos of x square plus y as it is, and then derivative of x square plus 5, the derivative of x square is 2 times x and then derivative of 5 is 0, right? So what we get here? 2x plus 0 is 2x. Let me write it here. And then cos of x square plus 5. Okay, so now this is the required derivative. Let me take one more expression. Y is equal to sine of x cube plus 3x square plus 8. If you want, you can pause and then try to solve this one. Same steps, just refer the previous one and follow the same steps. So now here dy by dx will be first derivative of sine, cos, and this as it is x cube plus 3x square plus 8, okay, into d by dx of the second expression x cube 3x square plus 8. So now here cos of x cube plus 3x square plus 8 will remain as it is, and derivative of this, right? So again just the same xn formula. X cube derivative is 3x square plus 3 constant as it is, derivative of x square is 2 times x, and the derivative of 8 is 0, which is a constant, right? So now here cos of x cube plus 3x square plus 8 as it is into 3x square plus 6x, okay, or you can just write it as 3x square plus 6x into cos of x cube plus 3x square plus 8. Okay, fine. So let's take one more question from the exercise. So here we have cos of sin x, right? Both the trigonometry functions. What if we have both the trigonometry functions, cos of sin x? So now if we have the given function y is equal to cos of sin x, okay? So now how to differentiate? Again, 1 and then 2 different functions. So first dy by dx, you need to consider this one here, the derivative of cos, right? And what is the derivative of cos? D by dx of cos of x is equal to minus of sin of x, that we know, right? So similarly here, derivative of cos will be minus sin and then see x as it is. So similarly you take this sin of x as it is, don't make any changes. And you are finding derivative of cos of sin x, you need to just take the derivative of cos and then keep the angle or the expression with the cos as it is, don't make any changes here, right? Because I have seen most of you differentiate in the first step itself. You take cos as sin and then again you take this sin as cos of x. Don't do that. Keep the sin x as it is. In the next step, you take the derivative d by dx of sin of x. So what we get here? Minus sin of sin x into derivative of sin x, that is cos of x. You can write it as minus of cos of x into sin of sin x. Okay, so let me take one more similar question here. So if I take y is equal to cos of sin of x square, okay, y is equal to cos of sin of x square. So here we have cos, we have sin, again we have this x square here, total composition of 3 different expressions, right? Cos, sin and then x square. The steps will remain same again, but here you need to differentiate 3 times, 1, 2 and then 3, right? So now dy by dx will be, okay, first take the derivative of cos. So what we get here, minus sin, again this one as it is without any changes, you write this sin of x square as it is, right? So we are done with the first derivative. Now we need to differentiate the second one. Let me just write it here, d by dx of second expression sin of x square. So now here minus sin of sin x square as it is, and then derivative of sin of x square, take the derivative of sin cos of x square into d by dx of x square. So we are done with the second one. So now we need to find the derivative of third x square here, right? So minus sin of sin x square as it is, and then cos of x square as it is. Derivative of d by dx of x square will be 2 times x. Okay, so at the end what we get here, 2x dot cos of x square dot sin of sin x square, and you can take the minus sign here. Okay, fine. So let's solve question number 3, sin derivative of sin of ax plus b, right? So this will be similar to the first question. Let me solve derivative of sin of ax plus b. Okay, so here if you take y is equal to sin of ax plus b, so dy by dx will be, again here we have 2 different expressions, sin and then ax plus b. First you need to find the derivative of sin and then this here. And what is the derivative of sin? Cos of ax plus b. Okay, and then take the derivative of second one. The derivative of ax plus b will be, derivative of ax is a and then derivative of b will be 0. So you can just write it as a times cos of ax plus b. Okay, so next we have one more similar question here, that is sin of ax plus b cos of cx plus d, right? So let me try this one. Question number 5. Sine of ax plus b cos of cx plus d. Let me take next page here. Question number 5 from your exercise. If you take y is equal to sine of ax plus b and then cos of cx plus d. Okay. So now here, I hope you guys are comfortable with this u by v formula, right? What is u by v? Dash is a derivative of u by v form, right? If you have numerator and denominator, two different expressions in the numerator and denominator, then you can use this uv formula. So here, what is this uv? You need to take v square here and then u dash v, derivative of the first numerator, right? Derivative of the numerator, and denominator as it is minus u v dash. Okay. So now here, this you need to consider as u and then this one here v. So what we get here, dy by dx will be equal to a square of the denominator cos square cx plus d. Okay, cos square cx plus d, and then u dash, that is derivative of, let me just write it here, d by dx of sine of ax plus b, okay, into second one as it is cos of cx plus d, and then minus first one as it is sine of ax plus b dot d by dx of cos of cx plus d. Okay, so now here one derivative, derivative 2, these two expressions as it is. So now you keep the denominator as it is, cos square cx plus d, and then take the derivative of sine of ax plus b, right? Similar to the previous one. Derivative of sine is cos ax plus b as it is, and then this is my second expression. Here derivative of ax plus b is a, so let me write it here, a dot cos of ax plus b, and here into cos of cx plus d. Okay, minus sine of ax plus b as it is, and then derivative of this one here. So derivative of cos is what? Minus sine of cx plus d. Okay, minus sine of cx plus d, and then derivative of cx plus d will be just c here, right? Because this d will become 0 here, this b will become 0 after taking the derivative, right? So then you will be left with just c here. So what we get here, the final expression will be cos square cx plus d will remain as it is, and here a cos of ax plus b, and then cos of cx plus d. Okay, and then here minus into minus we get a plus here, and then sine of ax plus b, and then here sine of cx plus d, and this c, if you can, let me just write it here, right? C into sine of cx plus d. So this is the derivative of sine of ax plus b cos of cx plus b with the formula u by v whole dash. Okay, let's take one more question from your exercise. So we are done with 1, 2, 3, 4. Okay, let me take question number 4, secant of tan root x. Okay, secant of tan root x. Question number 4, if I take y is equal to secant of tan root x, again here 1, 2, 3, different terms we have here, or the functions we have, and we need to find the derivative. So dy by dx will be written as derivative of the first one, that is secant. What is the derivative of secant? D by dx of secant x will be equal to secant x tan x, right? So secant x dot tan of x. You need to remember all the derivatives, right? Better you make a separate sheet and then write all the derivatives, because it is very difficult to memorize all the derivatives, integrals, trigonometric formulas in a single go. So write it, keep on solving the questions, then you will be used to each derivatives and then trigonometric identities, right? So now derivative of secant is secant and then tan. So what we get here, secant tan root x. Again, keep this expression as it is in the first step. Secant, instead of x we got tan root x into tan of tan root x. Okay, so now take the second one into d by dx of the remaining expression tan root x. Okay, fine. So now you write this one as it is, secant tan root x into tan root x. Okay, and then derivative of this d by dx of tan of x is equal to secant square x, right? Derivative of tan of x is what? Secant square x. So what we get here, secant square root x, again third one root of x, d by dx of the third expression root of x, right? So at the end what we get here, secant tan root x as it is, tan root x as it is, and then secant square root x here, and then we have the derivative of root of x. Okay, then we have the derivative of root x, which is equal to 1 by 2 root x. Okay, why it is 1 by 2 root x here? If I take d by dx of root x, and what is root x? What is this root here? We know root is x raised to 1 by 2, right? When we have 1 by 2, we take it as a square root. So now if you apply the general formula x raised to n, if I consider this as n, what we get here, 1 by 2 as it is, x raised to 1 by 2 minus 1. So 1 by 2 x raised to minus 1 by 2, right? Which is equal to 1 by 2 x raised to minus 1 by 2, 1 divided by x raised to minus 1 by 2 plus 1 by 2, right? Laws of exponents. If we have a raised to minus m, we get 1 by a raised to m. Similarly, if you have x raised to minus 1 by 2, 1 divided by x raised to 1 by 2. This can be done as 1 divided by 2 times root of x. Okay, so instead of all these steps, you just remember this one. Whenever we have a root of d by d of derivative of root of x, you can just write it as 1 divided by 2 root x. Okay, fine. So at the end you can just write it as secant square root x, this one, divided by 2 root x into secant tan root x tan root x dot. Okay, that's it. 1 2 3 4 expressions here. Okay, all right.